been a bit of a rough week for me, so there were some gaps in the uploads, but now I'm back with some more of educational content. I just couldn't keep you waiting for too long. Today I'm going to describe the purpose of VMware vCenter, and we'll go through a few settings, through main functionalities, and why do we need this kind of application. And in the end, I will elaborate on a bit more advanced features, and we'll see how can we actually operate everything that we need to know for now through the interface of the web browser. But we will start with basic explanation. So this video is a direct continuation of the previous experience with VMware ESXi, but I will make a few reminders so you don't have to go back and watch the most basic things. So we have, let's say, one ESXi server, and the purpose of this server is to host your virtual machines. So it's single hardware host, but inside of it you'll have multiple VMs working. Let's say we have VM1 and VM2. So if you recall, what is a VM? VM is a process. So this is a process, let's say, with PID 930. It's a program which is running on the ESXi, and it is an emulator of Windows operating system, let's say. And because it is a program, it needs files. And as we discussed, the machine will have at least VMX, which is the configuration file, and VMDK, which is the disk. There could be multiple VMDK files. So these files will be present on a storage, and the machine will use them. So there is some kind of storage box connected to ESXi. It could be a local disk, it could be a NAS box, it could be a SAN device, but this is basically a specific LAN. We'll call it data store, and data store is where you store the files of virtual machine. So there will be a VM folder with VM files on VM data store, right? Everything is fine. You can run multiple machines, but what if you need to shut down your ESXi server, right? Well, you would have to basically shut down all the virtual machines on it. However, there is a way to avoid that if the machines are critical or important. For example, if you want to reboot the server or do some maintenance, you could have another ESXi server, and you could try to move the machine from one server to another. So it would start working on the second server. Makes sense, right? But how would you do that? The server would have to have access to the same storage. So the data store would have to be connected to both servers. And in this case, it's already a shared storage of type of usually NFS or iSCSI or fiber channel connected device. So you couldn't use local disks for that. So if you want your machines to be able to move between your ESXi servers, you would want to have some kind of SAN storage or NFS share. Okay, that's fine. But when you move the machine, it would have to be removed from the database. So if it was VM5 here, it would be deleted. You would no longer have VM5 on the ESXi, and you would have to register a new machine. How could you even do that? Well, theoretically, you could go and manually remove it from the interface here, and then you could register it from VMX file. So that's something you can do without any special clustering. But this would be too much, let's say, manual work. And then if you want to manage the machine from some kind of top level, and if you have hundreds of machines, it's very difficult to work like this. So you would want to have some kind of cluster entity. Pardon, my pen has gone crazy. You would want to have some kind of cluster entity, and that entity would want to track the machine and move it from one host to another, right? And would know it's the same machine. Let's say it's VM25. So even though you remove it and move it back to the other ESXi, the machine would keep the reference. The reference assumption I mentioned, it's called memoref, managed object reference, and this is an ID that basically defines the machine. So in order for all the commands and requests and user actions to target the machine, it needs to have some kind of ID. So normally it's a number. However, in this case, we want to have a global number, basically something that is above the ESXi. So simply using ESXi, you would be unable to cluster data. So this is where a special kind of role comes in. It's called vCenter. So vCenter is a VMware clustering solution. It's a database which contains data from multiple ESXi servers. And even if some machine leaves one ESXi and moves to another, vCenter still knows about it. So in this case, on the host, we would have references. Let's say this was machine 1, this is machine 2. And here we didn't have any machines. So if you would create a machine, it would get reference 1, moref. And you would lose reference 2 from the first ESXi, right? However, on vCenter, this machine would already have reference VM-2. So on the vCenter, you can clearly see from the reference that it's in the vCenter, the machines have VM dash and then a number as a reference. So the machine would still keep the same reference and you could control it. You could even keep it running. So what actually happens? The machine gets paused here. The control switches to another host and then the machine gets unpaused. So for the user inside of the machine, you wouldn't even notice that the machine has been moved. There could be a bit of a delay or stun, but it would work anyway. So the vCenter primary goal is to be able to move machines between ESXi servers. Also, vCenter itself is not the only, let's say, a layer of abstraction of organization. Actually, if you have multiple ESXi servers in the same place, you could put them in data centers. So you could create one data center out of 3 ESXi. The data center will still be controlled by vCenter, so it's like an intermediate unit between total top vCenter and ESXi below. However, the data center itself doesn't really, let's say, doesn't mean much. It's a specific, let's say, organizational ability or organizational quality. You can create it as a user as a folder of files, but it doesn't really mean anything physical. It's only logical. So for example, if you go to the vCenter here, there is a data center below vCenter, but it's just a group of hosts. So it doesn't mean that I have a real room. Theoretically, I could take 2 hosts from 2 physical data centers and put them in one logical data center. Like this is something that administrator simply creates for easier organization. But generally, the rule of the thumb is to create a data center of real data center. This way it's easier to understand the requests, the commands to other IT guys, and you wouldn't have confusion. So in this case, there are 2 hosts in the same data center room. That's why they are put in the same data center. Okay, let's get back to the picture. So let me clean it up a bit. The idea is understandable, right? We are moving the machine from one host to another. In which case we would want to do that? One of the situations could be that the server is going down. We decommission it or we reboot it, and in that case we could move it just to keep the machine running. Another situation could be that the resources like CPU and RAM on the host would go through the roof, and then you would want to move it. However, you don't want to have a person sitting and moving the machines around. So there is a load balancer built in vCenter which you can enable. It's called if I remember correctly, DRS, distributed something, but basically that's the system which allows vCenter to automatically move machines, and you can enable this and disable it for specific machines. For example, if you have like a VM exchange and you want this machine to always run on the server 1, you could disable this functionality, so no DRS. But other machines would move around. Another thing that is useful to know is that the machine could be moved not only because it's consuming too much resources, but because there is a special resource pool created. So you could create a smaller resource pool, let's say of only 10% of CPU and 25% RAM, and create it across multiple data centers or multiple ESXi hosts. And you could keep your less critical machines, like let's say the machine which you don't care about, for example, cat videos. I'm sorry. But there is a cat videos machine which you would keep in this pool with other machines you don't need. And if this pool is full, the machine would be moved automatically to another server within the same pool. So You would still have resources, but you would run out of specific resources assigned for this machine. Okay, and the worst case scenario, that something that could have happened without your direct involvement, it could be that the server simply died, right? So if the server would die completely, so it would just shut down or crash, the machine would crash too. But there is a system called HA, or high availability. And this system would automatically start up the machine on one of other hosts using the existing VMX and VMDK files. So this way you can make sure that even if your ESXi host crashes, your critical server like Active Directory or database goes up. Anyway, it doesn't happen immediately, it takes some time to boot the machine, but it's almost immediate. So you would get some disconnect for the user, some errors in your database activity, but a few seconds or maybe a minute later, if you have a slow system, it would be back up and running. You will also ask what's going to happen if the vCenter is on one of ESXi hosts. So here we have vCenter VM, and ESXi goes down, right? The idea is the same. The vCenter VM would restart from its own files on another ESXi using high availability. So high availability works even without vCenter when it's down, but you configure it through the vCenter. All right. One more thing, you don't need to actually have the shared storage between two ESXi servers to move machine. Like, it's not the only feature that you must have, like SAN storage. So this move, when you move the machine from one host to another but keep it in the same place, this is called vMotion. However, there is one more functionality called storage vMotion or svMotion. So if this data store wouldn't be shared, if it was only part of one server, like a local storage, there could be another data store which is shared, and before moving the machine, you could move the files to that data store first, right? And then it would become available to another host. So if you move the machine files, this action is called svMotion or storage vMotion. So these are two different functionalities, and you can combine both actions to completely move the machines around your data center. Okay, so that's what it is about the files and locations. Let me quickly show you how would you do it in the interface of the vCenter. So the difference you see in this case, I'm not connected to specific ESXi. I see the data center because instead of using the name of ESXi server, I'm using the name of the vCenter when I use the web browser. So the interface for vSphere would be the same, but there would be more functionality which comes with the vCenter, which involves clustering. So let's say I want to move this machine around. I would right click the machine, select migrate, and here I can select the type. Change computer source, it is vMotion. Change storage, it is storage vMotion, or change both, and that's storage vMotion and vMotion. So you could migrate machines between hosts, and you can move the storage without shutting down the machine. Because what happens, there is an NVRAM file, which is like a memory snapshot. So the machine would be paused and unpaused using this file. So let's say I'm moving it, then I'm just selecting a different host, and that would let me go through. I could also change the network, but I'll explain the networking shortly. So this is the only button you need to know, right? Click migrate, and then you can move the machine however you please. It's very simple, it's very easy, but it takes some time. So I would think you would ask me, how does the migration work? What does the speed of migration belong to? So in order to answer this question, I must explain what is a management network. So if we go back to vCenter and we go to networking here, there are a few networks available, right? And one of them should be management. Yeah, unfortunately, at the moment, I don't see the management because I'm not the administrator. I can show it on another server I deploy myself, but here you would have a VM network, the management network. So what is a management network? The management network is a specific network that exists for vCenter to control the ESXi. So the connection from vCenter to ESXi here happens on management network. And it's very important which network adapter do you use for this, because what's actually happening on the SXI, you have the real physical network interface card, and it could be 1 gigabit, it could be 100 gigabit. And when you create a network, let's say here you make VM network, you select which NIC does it use to go out. You may select no NICs and then it would be purely internal, but you couldn't connect to anything outside of this network. Or you could make it a network which is external, and then you would connect to the NIC. So it will greatly impact the speed of transfer of data between hosts, like migration, if you would pick a network card with lower network throughput, definitely. So this is something to pay attention to. You would want to select a specific card with the throughput that you expect to use for migration, and also maybe a bit more, because the vCenter itself has some overhead on actions. You may use backup application which will use this network to download data, and you may have a situation where 2 or 3 SXI hosts go down, and you would want to be able to move the machines fast if you want to migrate, let's say, storage for some reason after this crash or after maintenance. But I want to elaborate on networks a little. So what are the networks? How does the networking work? We have to take a look at a bit of a distant picture here. So most of the networks you'll see in ASXI are not real networks. They are logical or virtual networks, right? So while the machine does have the cards, let's say these are 2 physical cards. By default, like most of people use 1 gigabit, unless it's a busy server and I don't need this PID anymore. Let me get rid of it. You will run some processes. You have VM1 as a process and VM2 as a process. And because these are virtual machines, they will emulate real systems. Let's say we have Windows XP on one of the machines, and we'll have Windows 2008 on another machine. So in the Windows, you'll have a network card here. So this will be usually VMXNet free. It's an adapter which is used by VMware. So if you see this adapter, it's clearly a virtual machine if you see it from inside the Windows. So there will be normal traffic back and forth, TCP/IP, using the network card. And you would want these 2 servers to communicate. So in VMware, you would connect them to, let's say, network called VM network. So the real question is, what's happening here? How does one virtual network card communicate with another? Well, since both of these are just application, let's say PID 100 and PID 101, when the data goes between 2 applications on the server without going out, there is no real networking involved. There is emulated networking, but everything goes through memory, through RAM. So there is like a tunnel virtual network in virtual RAM, but real data, like bits and bytes, go through the processing power of the host. So this does not really connect to any outside real physical network. If you do want to use it like this, you can simply create an internal switch, because the network needs to have some switch assigned. In our idea, usually it's a gateway or a switch. So there is a thing called standard switch. Standard switch. So this standard switch is also a configuration, let's say a process inside of ESXi operating system, which will support managing memory like network. But you will be unable to get out. What you can do, you can assign this switch to a real physical card, and then it would act as a router. So you could have internal LAN, and it could get out, and then you could have another standard switch 2 on the server, number 2, and then you would have VM network 2, and this switch would also use this network card as a router, and now you have two NATs, not here, and you have two networks. However, if you move machines between hosts, you would want the machine to stay inside of the same network. Makes sense. So how do you make it work? Well, this setup wouldn't work. What you can do, you can configure another type of switch. It's called distributed switch, dvSwitch, distributed virtual switch. And this is a switch which gets created on a layer above ESXi. So this switch would encompass multiple ESXi servers. And because it's global, it's obvious, I think it is obvious, if not sorry, but it has to be a property of the vCenter. So you can only make networks which span multiple hosts using the vCenter. And then the vCenter would manage traffic as though it was like VPN tunnel or something. So it would use its own technology. And then you could have the same network. So it wouldn't be VM network 2. It would also be VM network on both sides. And in this case, you also need to select which switches. So let's say you could have another network card here. Let me use a different color. So you could have a card number 2, and you could select that this switch now uses these cards instead. So this configuration allows you to basically pass through a virtual network through multiple hosts. And when it would travel between physical servers, it would use real cables. So there is no doubt it's real networking. But within the ESXi, it would use memory as a virtual network. And a bit of information about the terminology. The switches, like the logical entities which contain networks, are called virtual switches, vSwitches, and the networks are called port groups, port group, because it's like ports on the switch. If you would have physical switch, you would have physical ports. I'm not talking about TCP or UDP ports, physical ports. And a group of these ports would be used as a network. And this is why these networks, like VM network, are called port groups. So let's take a look at what I can see here, and then I will connect to my ESXi just to give you more insight on this. So here, if you go to networks, we have distributed switches. There are no standard switches, so that's the only option. Otherwise, you would have standard switches too. And now there's a shared switch. If you click on it, you will see that it connects two hosts. And also, if you go back within the vCenter, you control distributed port groups. So there are 3 networks, which are basically, you can imagine it's like a big switch with multiple VLANs. I didn't explain VLANs on my TCP IP video, but basically it's another way of tagging networks. So if you have a big switch with many cables, you can use multiple subnets and you could tag them with different VLAN ID. It's just a way to segregate or separate traffic in different subnets. So here we have 3 subnets. And these 3 networks connect to different VMs, as you can see. So if the machines are in the same distributed port group, in the same vCenter, they can freely move between all the hosts connected to the switch, distributed switch. And then they would still stay in the same network. Okay. So I wanted to show you how do you define this connection between the ESXi and vCenter and the management network. So the management network, this specific type of network which is used for migration of machines and control of vCenter, it's called VM kernel IP interface. So you select specific IP address on the ESXi and you mark it as VM kernel IP, which will be used for the transfer. And if you are interested in the actual, like deeper meaning, there is a TCP channel open on port 902, and this is the port used for communication between the ESXi servers and vCenter. So it's port 902 on VM kernel IP. I'll quickly connect to one of my ESXi servers and show you. So now we are connected to the host. You can see there are less options. I cannot create data centers or clusters. I can only see the virtual machines I have. And on the host, in the manage section, you also see networking. Let me find it. Manage. It's below here, networking. Okay. So here you see port groups. So these are virtual networks. One of them is my management network, but I'll show you why. There are virtual switches, and because it's a standalone host I created, here it is, it's not part of the vCenter. These are standard vSwitches, so I can use them as routers or as internal switches, but I cannot span them across multiple ESXi hosts. And you can see there are 2 port groups on one of them and one on another. And if you go to the port groups, you can see which switch they are on. And then if you create the machine, you can go to the settings of the virtual network card and select which port group the machine is assigned to. And here we have physical NICs. So this is a real card we have, which is VM and VM NextNet free. It's a specific driver, but this is a real physical server, supposedly card. In my case, it is a virtual machine. This is why this card is VM NextNet free, because it's a nested ESXi. But if it was a physical server, you would have some kind of standard network card. It's 10,000 megabit per second. And if you go to the virtual switches, you can edit the switch. And here you select uplink, which links it to a specific physical switch. So now you know that when you want to get out the real internet using the switch, it will use this physical card. You can also configure other things like teaming. If you have multiple team NICs, you can select failover. So if one of NICs goes down, you can use another one. But right now I have only one NIC, and this is why it doesn't make much sense. Right. So there's one more tab which is called VM kernel NICs, and this is what is important. So one of the port group, I called it bad network because I was playing around with this, right? So I assigned this network as VM kernel NIC. It means that this public IP you see, and this network, and this VMK0 physical card will be used for communication for management purposes. So if I install a vCenter, this will be my network. If I had multiple physical network cards, this one would be used for connection between vCenter and ESXi. Okay, so let's delete everything because it's a bit of a mess, and quickly go through what we discussed today. I want to wrap it up because it's pretty late, but I want this to be useful, and I'll repeat what I said. So there are ESXi servers. Let's say you have multiple ones. And each ESXi can run multiple VMs as processes. So we have VM1 here, which uses CPU and RAM, VM2, and another server has VM3. So if these are fresh VMs and no VMs existed before, this would have reference 1, this would have reference 2, and this would have reference 1. If you would unregister and register a machine, it would get incremental reference, right? So if you would want to move the machine 1 to server 2, it would lose the reference 1 and would get reference 2 here. And you would basically lose the machine because the reference defines what machine is. So you can deploy a vCenter, and vCenter is a top-level database and server which controls multiple ESXi. And this vCenter would use VM kernel network interface card from each of the ESXi server for communication. Here also VM kernel network interface card, port 902. So if the port is blocked in the network, communication would be possible. And these cards are also used to communicate between ESXi hosts. So when the server moves, it goes through this network. And because it's a global database on the vCenter level, this machine, even though it moves, it will still keep the same VM1 reference. So we wouldn't lose the machine for backups, for scripts, for control, everything, right? Inside of the specific vCenter ESXi servers, you would have local standard vSwitches, which you could use for inter-machine communication, and everything would go through RAM. But if you want to have a network which spans multiple ESXi, you would use a distributed vSwitch, dvSwitch, and this would exist on multiple ESXi hosts at once. And something that may be important if you want to deploy it, I will tell you what kind of deployment the vCenter itself is. So you have bare metal hardware, like a real computer with CPU, RAM, and everything. Let me fix the second one, it's too sideways. Right, so here you have CPU, RAM, and you have two computers. So you would install the ESXi as operating system directly on bare metal systems. So on top of your hardware, it would be running operating system in your hardware. If you want to cluster it, at first you would want some kind of shared storage. So some kind of storage device. It could be NFS. It could be iSCSI connected. It could be fiber channel connected. And then you would want to have vCenter, which is actually a virtual machine on one of the servers. So while it controls everything, it's running as a VM. And if the server would go down, it would go up by high availability. Now, the VM itself has to have operating system. So typically it could be a Linux appliance, or it could be a Windows server. So for Windows, you install vCenter service. There are a few other services like single sign-on and other, but the main one is vCenter, which controls everything. For Linux, you have multiple daemons like VPX daemon, which controls the vCenter. And on ESXi, since they're Linux-like, you have VPX agent, VPXA. So if you see VPXD and VPXA services, these are a bunch of, let's say, a bundle of products, programs which run together. So daemon controls multiple VPX agents from the same vCenter to multiple hosts. For example, if ESXi stops responding to vCenter, but it works as a normal server and you don't want to reboot it, the first thing you could try, you could start the DCUI, the console, and restart VPXA. I can show you how it's done. It's pretty simple. So if you log in not in the web interface but in the console of the ESXi itself, it looks like this. And you can press F2. You can log in as your root user. Hopefully I don't forget the password here. And here, if you press F2 again, you'll have access to internal configuration. And here there's a button, Restart Management Network. So this is something that restarts management network, the VPXA management agents. If you do that, you would basically interrupt your DRS, your specific vCenter related services like vMotion. So you don't want to do that when there are transfers in progress. But if the machines are sitting on the hosts and one of the hosts is not responding, so it's not using this agent anyway, you could go here, press F11, and within a few seconds, look, it's up and running. So you should do it at your own risk. It will interrupt activities such as migration of machines, but if the server is not responding to vCenter actions, that would be the first step you do before you actually reboot the server. I mean, you wouldn't have a chance to move the machines normally anyway if the migration doesn't work. So that's something that can be as a temporary solution or maybe a solution to the problem. One more thing to take into account, you need to know which physical card you use for the communication, because if it's a slow network card, the operations such as migration would be also slow. And finally, there is something that I would like to show you, but please be careful with it. Basically, only if you want to test it in the lab or if you're a database administrator. You have two ways to access vCenter database. If it's Linux, it's probably on Postgre or Oracle, right? So here you would have Oracle instance, or you could have Microsoft SQL instance. So you could actually connect and see the database. Normally you wouldn't do that unless you troubleshoot something with VMware. But there's one more thing. You could go to the web address of your vSphere and add MOB, Managed Object Browser. So each machine is a managed entity. It has managed object reference, MOREF. And if you go to MOB and you log in under the user, which I'm pretty sure I don't have access here, so let me try. I mean, who knows? Maybe I do have access. Oh, I do. Nice. So here, Now it's like database with tables. You click on content. Here you can see various actions. So if you actually go through the actions, those bring you to specific API functions. And there is a group of your host data centers. Here you go to specific data center. Now you see the name. Now it's like tables of database. This is what you would have in your SQL. Here you have a group of VMs. So for example, if you click on the machine, now you can see different groups. I'm going to my private VMs, and here I should see my Denis Churaev group. Yeah, and these are my machines. So this is my SXI, which is now running. So let me take a look. Here I should have methods. And let me find, where is terminate VM? I'm clicking invoke. Unfortunate. I can see the operation is not supported on this object. So this method is not available at the moment. I could go to reboot guest. Let's see. Yep, and restart actually happened. So this is something that allows you to do way more than the web interface, because this way you basically get access to the vCenter itself, including its database and everything. I wouldn't recommend to poke around the method. There is a reason why vSphere web browser doesn't have all of them available. But this is a useful table space where you can find specific managed object references. If you are checking logs of application, if you are writing scripts, for example, here, if I'm in my machine, I can see that my machine is VM 18,815. So this is the managed object reference of my machine, of the SXI. And if I would like to write a script which would stop, reboot, check snapshots, or do something else with the machine, I could use this reference. So this is the access you can get if you use, let's say, VMware, a client interface, a command line CLI, or some other things like a VMrun utility. But I don't think you would have access to this normally unless your administrator knew that you have actually knowledge about this. But be careful. If you are not blocked from this, do not use it for nefarious purposes or for testing. It's only useful if you actually know what you're doing. But it may be useful for people who want to write scripts, because this is a way to access a lot of information. All right. So that should be the summary of it all. The vCenter is a Linux or Windows machine which controls multiple SXI servers, and it can move the machines around, and it can migrate them based on the load, and you can set up high availability, which would restart it even if one of its size goes down. It uses a network called management network of VM kernel IP on each host, and it controls VPXA agents through VPXD daemon. It has database which is either Oracle or SQL or PostgreSQL, and that's pretty much it. One more thing, it's not the topmost hierarchy. Theoretically, you could have the cloud director. It's kind of another level of organization usually used for cloud, where you can have multiple vCenters. But it is not used often, and if you actually manage the cloud director, you are probably on a level of advanced vCenter administrator. Otherwise, you wouldn't be let in that kind of environment. Just keep in mind that it exists. We can take a look at this later if there is interest. But right now, if you have access to free SXI, I don't think you can deploy vCenter. But if you have a lab somewhere, like, or if you have questions, how does it work at work, or at your local organization, feel free to ask any questions. I'll definitely make more videos, even though I'm a bit tired. You can see I'm a bit slow today. And I will be happy to answer questions. I have got just a couple of questions so far about books which can be used for learning. If you have any kind of personal interest in IT development of yourself, I'm not a total specialist in the area, but I do have some background and some experience with training. So I could at least share knowledge about some documentation which I use for teaching. I'm also thinking about making an advanced VMware training for a few hours, but it's going to be a large video which will take a lot of resources. And it will compile basically all of this information in a more structured manner. Right now I'm trying to feed you like small portions so you don't get bored too much. But if you want to look at any specific feature, I'm looking forward to further questions, and I wish you a great evening, great night, great morning, whatever you have. Stay happy, stay safe, stay healthy, and I'll see you in the next video. Bye bye.